This is Science 1120, Lab 2. Lab 2, we're going to be doing power consumption of incandescent CFL and also LED bulbs. So, what we have here, we're going to be measuring the power, which is in volts. The volt power, which would be the voltage, times the current. And what I'm going to do, since it's kind of hard to do, I'm going to do this lab for you. We have a circuit hooked up with a power supply to a conventional incandescent bulb, and we're going to measure the voltage and the current, and then the power will be P is V times I. So I'll be doing this and doing the numbers for you and showing it so you can get it and complete the lab. So this is the handout, which is on the Lab 2 place. And what we're going to do is then turn it on, have it run, and I'll do it and start it now. So we're measuring the voltage, which is here. The voltage is 122 volts. The current, which is in amps, is 0.62 amps. Now I'll show that for you here. Okay. So approximately 120 is okay. We're using 120 for voltage, which is standard household voltage. Then the power, which I showed you earlier, is V times I. The power will be 100. I'm going to use 120 times 0.62 is approximately 75 watts. So we multiply the voltage times the current, and we get approximately 75 watts. And this is how much power a 75 watt bulb consumes. So that's it there. SI units for power is watts. All right, so that's the first part there. All right, what I'm gonna do next is try to measure how hot this thing. Basically an incandescent bulb, 90% energy is wasted as heat. So what I'm gonna do is, I have an infrared thermometer, which I'll use to get the temperature. And we can see it's 184 degrees. 184 degrees Celsius. So it's extremely hot. So I'm going to turn this off and then try to take this down. Do this because this lamp is very hot. Okay. Now what we're going to do is put in the compact fluorescent bulb. Right? This is an older one. Right? Compact fluorescent bulb, or just a fluorescent bulb filled with mercury. And I'll do that. So I'm gonna replace it, everything's the same. I'll then turn on the power. Okay. Now for this one, the voltage is still the same. The current, on the other hand, is about 0.14. Well, let's see what it does. There we go. Let's see. Well, it's starting to get going here. Okay, approximately .16. Let's see. So the voltage is 120 volts, just like it was before. The current, though, is 0.16 amps. So what is the power generated? The power used by this thing, the power will be 120 times 0.16, which would be, let's see, that's 12, approximately 20 watts. So we take 120 times 0.16 and we get approximately 20 watts power. So it puts out the same amount of light, but it only uses about 1/4 as much of the power. Now if you take the temperature, it's warm, but I can still touch it. And if I take all right, so it's around 60 degrees Celsius. Warm, yeah, warm. I mean, wouldn't want to keep my hand on there too long, but it's still far cooler than it was before. So that's the compact fluorescent bulb. You can calculate that, do that for the next part of the data table. And we're going to do is then replace it with an even more efficient bulb, the LED bulb, which and these are the newest one. This is actually fairly, we've had this for a while, but the newer one's even a lot prettier. And what we're going to do there is turn it on, and it is so cool because almost all of the light, the energy goes into the light, so the thing actually feels cool. I can put my hand on there and hold it all day. And in this case, voltage the current is about amps. So the voltage, let's see, let's make it 0.1. Yeah, 0.09 amps. So the voltage is still 120 volts because that's how household voltage works, but the current draws 0.09 amps. That's a 9. And so the power consumed will be 120 times 0.09 is approximately 11 to 12 watts of power. 11 to 12 watts of power is what's used here. So that's for the LED bulb. And again, the thing feels cool because almost all the energy is going into light. So the comparison, answering the question, which put on most heat, which one would be the cheapest to operate? Because operation is how much power it consumes. All three of these put about the same amount of power, but if it uses less amps, it's using less wattage and therefore less cost. Okay, last question here. Last part here on question is you're going to calculate how much energy it takes to operate a 100-watt light bulb for a month. Okay. So an incandescent lamp. So if it's left on for a month, it'll be 30 days times 24. So you calculate how many hours that is. Then 1 kilowatt is 1,000 watts of power. So calculate how many kilowatts is 100 watts, because we're going to pay for energy in terms of kilowatt hours. Then energy consumed, so it's going to be power in kilowatts times the number of hours. So it'll be the number of hours you calculated over 30 days, 24 hours a day, times whatever this is. That'll get you a number of kilowatt hours used. And then the cost will be your answer E in step 3 times approximately 10 cents a kilowatt hour. And that'll tell you how much it would actually cost to run a 100-watt light bulb, a standard 100-watt incandescent bulb, over the course of a month. Okay, so that's lab 2. You get 2 attempts for doing the quiz. We'll see about that, and we'll move on from there. So have a good day.